Okay, so we move on to the system architecture. I'm going to now, I will show you a video of actually the vision that we have for the project. We have prepared a video that's 5 minutes long. I'll try to comment on top of that. What we imagine for BRISEIDE is actually a scenario where the user can log in through a web-based system. That's actually the 3D GeoBrowser that we have developed and that will be used as a basis for BRISEIDE. And the user then can log in by using his credential, and then according to his privileges will be able to access a certain number of features. For instance, he can access real-time digital terrain model. All the imagery is sent via standard OGC, OGC standards such as WMS or WFS, wherever appropriate. On the right, there is a table of content that provides access to the different layers relevant to the given scenario. So far, so good. Basically, this is all about accessing data, which is indeed very important. In this case, for instance, we are accessing a number of data available from Provincia di Trento, which will be available again which will be made available to BRISEIDE. And this is the master plan of our province. So as you can see, the idea is to provide access to the range of data within a single and user-friendly environment. But in fact, what we want to do is much more than this. What we want to do is not only providing access to data, but also providing access to services and to special temporal processing services, as you will see. Some other things that are possible to do is overlapping of data set, changing the priority of different layers. These are pretty much standard features of our technology. Again, the legend is created automatically according to the different data which is being created. And this is all done in an interoperable manner. The idea being of making use of existing resources from the other European projects or resources and data made available by the data provider. Then on the left-hand side, you will see that in a minute now, a new panel will open, a new menu will open that actually enables the operator to access to more complex functionality. Let's leave the movie rolling so we can see it all. Again, it is important to notice that this application is web-based. So basically, this will be made available to the different operators by just clicking on a web link that this is a website application, and it does not require any software to be pre-installed on the system. Besides having a Java virtual machine because it's all based on software. And move on. In the scenario that we are foreseeing, then after the user, the operator in this case, wants to predict the effects of some pretty better weather forecast coming. So in this case, information coming from real-time sensors are accessed from the system. So in this case, we are accessing live information from meteorological sensors available within our province. And as you can see, this can be done in a very user-friendly manner. Basically, the operator flies over the area of interest, and then sensors information are rendered in a number of different ways. In this case, for instance, we are rendering them as a sort of 3D pie flying over the terrain, and this pie, the different sectors of this pie actually are the different measurements that the sensor can provide. And as you can see, you can make a special temporal query, and at that point you retrieve from the database the evolution of that given data set that you might be interested in. And you might also see that next to each of the different sections of the pie, there is also an arrow, red or green, that tells you whether the current pattern might be dangerous or not. Then, moving on to our logical abstraction level. What the operator can do can also access a number of geospatial services. For instance, in this case, we're accessing a number of WPS, web processing services. So what the operator is doing now, the user is doing right now, is dragging and dropping those black boxes on the scene from the library we have seen. So what happens is that the operator knows that he has to run a flood simulation. He drags and drops on the scene a number of different blocks. Each of them is responsible for a given processing functionality. The idea again is to simulate flooding in a given area. So the first block, it's a WPS, the rendering of a WPS, which is responsible to search within the repository the number of sensors available within a given area. The given area is the right one. Then, as you can see, these are all connected together and orchestrated very easily. Let me pause the video for a second. So what happens is that the first black box is responsible to search for sensors available in the area. Then this information is passed on to a second black box, which is responsible to calculate the flooded area according to the live data coming plus a given threshold that you might want to have on top of the current value. The flooded area is passed on to another service, which goes onto the database, research streets which might be affected by the area potentially subject to flood, and then retrieves those streets and through another service invokes the list of people, of telephone numbers. Actually, what we are doing, we are invoking a web services which is available by white pages, Italian white pages. So you end up with a list of streets, the list of people and telephone numbers living in those streets, and then we use a geocoding service to get the coordinates of those people living in those streets, and the result is being rendered here. You can see it in the video. So at the click of a button, the system orchestrates all those services, and as a result, you get a list of telephone numbers plus the location of those who might be affected by the flood. And this is a live demo. We do everything with publicly available information. So how do we want to do this in the context of BRISEIDE? The challenge was to access standard data in a standard manner, to provide access to processing functionalities. This is just another screenshot. But the real challenge is to provide access to spatiotemporal processing capabilities. That means developing operators such as interpolation, identification of flocks, you name it. So a number of functionalities that can be used across all the pilots to make all those analyses which are essential in the context such as the one we are facing, which is basically civil protection. The real challenge in this case is to make sense out of this plethora of data which is available from the data provider. So making sense out of the data and making synthesis of this data. The idea is to prevent information overload, which is probably one of the key issues right now. Information overload is very relevant because we are accessing a number of repositories, as it has been mentioned today, at the national level, then at the EU project level, so to say, and also at a very specialized civil protection level, for instance, the Italian landslide inventory or other specialized repositories that are in use within the project. So the goal again is to make use of real-time information. You have seen, for instance, how we access information from sensors in province of Kraków. In this case, for instance, we will be accessing data from a number of sensors in our area, as well as in the case, for instance, of the Spanish pilot, where we will be accessing live data from vehicles and other resources deployed in our region. The starting point, from the technical point of view, it's the 3D geobrowser that you've seen in the video. Then technologies such as GeoPortal made available through CCSS. Then the announcers, which is a component developed by CPGs, which is basically all about data ingestion. I'll get back to this in a minute. And then the WPS library by PI, WPS or 52 North, which is also partner of the project, which will be extended to include also the special temporal services which will be developed during the project. In terms of services, we will be accessing a number of OWS made available by those European projects you can see on my app. I was mentioning the library, the WPS library, which will be extended. We'll be building on top of the existing WPS library from 52 North, and specifically on top of this extension, which is a geoprocessing library which has been wrapped with the WPS layer to provide access to geoprocessing capabilities, again, in a manner. The idea is to extend it and to make it available on the block.